With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students. Now, first of all, let us look at the question here. Now, the question says that which of the following statement or statements is or are correct. So, this is a multiple correct question. Now, the first statement says that transition metals and many of their compounds show paramagnetic behavior. Now, this statement is a true statement. Why? Because transition metals have one or more valence electrons or unpaired electrons. They have unpaired electrons in their d subshell, and due to the presence of one or more unpaired electrons, they show, or most of them show, paramagnetic behavior, right? So let me just write it down. So due to the unpaired electron, due to the presence of one or more unpaired electrons, okay, what happens? They show paramagnetic behavior, okay, behavior. So this is something that we can say based on the understanding that the transition metals, or most of the transition metals, have one or more unpaired electron, and whenever a metal has, or an element has, one or more unpaired electron, they generally show paramagnetic behavior, right? Now moving on, the next statement tells us that the enthalpies of atomization of the transition metals are high. Now this statement also is true, right? And the reason is that whenever we talk about transition metals, right, the Z effective keeps on increasing if we just move from left to right across a period, right? So let me just write it down. So on moving left to right across a period, okay, what happens? Generally, number of protons increases, right? Because number of protons is increasing. Why? Because I can say that Z is increasing, that is, atomic number is increasing, right? Atomic number is increasing. Now, when atomic number is increasing, the Z effective, that is the effective nuclear charge, is also increasing, right? And also we have valence electrons, the increment in valence electron is also seen, right? So all these are increasing. So just because of Z effective and this valence electron increment, we see a more stronger interaction between the nucleus and the valence electrons, and due to this reason we see a better binding, and the metallic bond gets stronger and stronger, right? So whenever this happens, we can say that the enthalpies of atomization of the transition metals becomes high, right? So let me just write it down. So when these two increases, we experience the interaction, or we experience the stronger interaction, okay, between the atoms, right? And hence I could say that metallic bonding gets stronger, right? So this is something that happens, and due to this reason I can say that the enthalpy of atomization of transition metals are high, right? So due to this, the atomization, or enthalpy of atomization, the enthalpy of atomization is high. Okay, just because of the increment of Z effective and valence electron, we see a stronger interaction between atoms, and metallic bonding is getting stronger. And when these are brought into a picture, we see that enthalpy of atomization is also getting higher and higher, right? Now let us move on to the third one, which says that the transition metals generally form colored compounds, right? Now this is also a true statement, right? Why? Let me just write it down here. So in transition metals, generally we see forming, transition metals generally form colored compounds. The reason is DD transition. So due to DD transitions, right, they form colored compounds. Okay. Now what exactly happens here? Now in the presence of a ligand, the d orbitals splits into two sets. Okay, whenever a ligand attacks, okay, so this is the d orbital that we have. So this splits into two sets. Okay, so we have here T2G, right? This is crystal field splitting we are talking about, and we have here EG, right? So this is the splitting that happens. Now if let us imagine that there is an electron here in T2G, right, which is a lower energy level. So sometimes what happens, this electron takes energy from the visible radiation, right, and it jumps from T2G to EG, right, and after some time it returns back to its original position at its original energy level, radiating the energy it has absorbed, right? And this is the reason why whenever this radiation falls into a visible spectrum, let me just write it down. So whenever this radiation falls into the visible spectrum, we see color coming out of it. Okay, color coming out. So sometimes this happens, right? So in the case of D block elements that are transition elements, we see unpaired electrons, and due to the presence of unpaired electrons, we see there is DD transition happening from T2G to EG, and this transition gives us a visible spectrum which is in the colored form, and due to this reason the compounds of we can say transition elements generally have some sort of color, right? So this is something that happens. Okay, so this is how we can explain this. So this particular statement also holds the true value. Now moving on, the last one that we have here, transition metals and their many compounds acts as a good catalyst. So this is also true. Why? Let us try and analyze it. So first of all, we need to understand that transition metals have variable oxidation states, right? So they have number of oxidation states which for them then becomes easy to form complexes, right? So transition metals shows, right, metals shows variable oxidation states. Okay, which helps them or which makes them eligible to act as a good catalyst. Okay, so this is the reason, and also they form complexes, right? So these are the reasons. So they form unstable intermediate compounds, right? They provide a new path with a lower activation energy of the reaction, and they also provide a suitable surface for the reaction to occur. So all this happens. So these are the reasons. So they provide, let me just write it down. So they provide suitable we can say surface for the reaction to happen, for the reaction, right? Also we can say they form intermediates compound. They form they form unstable intermediate compounds. Okay. What else? Also, we can say they provide a new path for for lower activation energy for the reaction. Right? So these are the reasons why we can say that transition elements are good catalyst, right? Or the compounds of transition elements are good compounds, good catalyst, right? So these all statements, all of these statements are correct statement, right? So this is how we can explain these type of questions. I hope you all also understand. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.